We are solving limits analytically. We have the limit of 10f of x as x approaches c. I'm claiming it's equal to 40. Now up here we have it defined. The limit of f of x as x approaches c is equal to 4. So we don't really care what the function is. We just know that this function and its limit as x approaches c is equal to 4. We've defined another limit over here. The limit of g of x as x approaches c is equal to 12. So this was one of our properties that we looked at earlier. This was the scalar multiple property. You can take this 10 and bring it outside. We have the limit of f of x as x approaches c is equal to, and now the limit of f of x as x approaches c, we've defined it as being equal to 4. And so we replace all of this with a 4, and therefore 10 times 4 is 40. Now this is a combination of the scalar multiple and the sum property of limits. We're going to break this up, as you can see, into two separate limits, and then we're going to go ahead and take these multiples here, or these coefficients I should say, and bring them outside. Now we remember that the limit of f of x as x approaches c, we've defined it to be equal to 4, and the limit of g of x as x approaches c, we've defined that to be equal to 12. And then we just do the arithmetic, and therefore I had claimed up here that it was equal to 132. Let's look at some more properties. Well, we've got the limit here of f of x, and it's all raised to the third power. As x approaches c, I'm claiming it's equal to 64. Now we haven't talked about this particular property, so let me go and get the theorem, and let's take a look at it. And I guess while we're there, we'll look at the product rule also for the next following limit. Okay, so the power rule is the one we're going to be looking at first. And as you can see here now in our problem, n happens to be 3. And what we can do here is we can take these brackets and bring it completely outside and put the limit of f of x approaches c inside. And you can see that this entire limit is raised to the n power. The next problem we'll be looking at is the product rule. You can break these up and take the limit of them separately. We might as well take a look at the quotient rule while we're at it. The limit of a quotient. You can also take these and break them up, taking the limit of the numerator and then the limit of the denominator. This works as long as the limit of the denominator of g of x as x approaches c is not equal to 0. Now let's go back and look at our examples. So as you can see here, we take this limit of f of x, right, put brackets around the entire thing and raise it to the third power. Now we've defined that the limit of f of x as x approaches c, we said was equal to 4, and therefore we replace all of this with a 4, and we raise it to the third power, which is 64. Now the properties that involve the product, two functions, we can break them up as shown in the theorem, and then multiply these separately, as you've seen here. Now the quotient property, remember we can take the limit of these separately as long as the limit of the denominator as x approaches c is not equal to 0. So as you can see, that's what I've done here. The limit of f of x approaches c. We've defined it, remember, to be equal to 4. And the limit of g of x approaches c, we've defined that to be 12. And when we simplify that down, we get 1/3.